Hi, everybody. So we're going to work on chapter 6. This will be the last chapter that we're going to cover before our first exam. And you might think it's kind of odd to cover a chapter about human population growth when we're talking about the environment. But hopefully by now you've figured out that everything is sort of interconnected, and the number of people on the planet are definitely influencing the climate and the environment. And so that's why we're going to talk about human population and how many there are and how many there are predicted to be and how do we study human population. So the first thing I'm going to show you is a short video clip which I think is really well done. It's basically about population growth, and it kind of shows where the population centers are in the world, where they've been in the past, and where they are now, and where they're expected to be. It starts off really slow. It's very interesting if you watch carefully watch the icons, and each little dot is going to represent 1,000,000 people. And it's interesting to watch, like in North America, how long it took for us to get to be 1,000,000 people here. Also, it has different historical significant things that are happening at different times historically that kind of go along with that time period. So it starts off a little slow. And if you remember what exponential growth is, you're going to get to watch it here real closely. So let me hit start and let's watch this video together.
An environment is a system of living things. The Earth is our environment. The capacity of our environment to provide space, to produce food, and to supply energy are all limited. Humans thrive on less than 17% of the Earth's surface, and only about 4% will grow crops. We depend on these limited resources for our survival, yet we are increasing our population as if they were infinite. This fact is at the core of our environmental problems. On this map, we'll show population growth from the year 1 CE to the present, and project our growth into the year 2050. Population concentrations will be indicated by dots, each of which will represent 1,000,000 people. In areas where people are spread out and don't live in concentrations of 1,000,000, dots are placed in the middle of their approximate range. Historical references will be provided by images and text at the bottom of the screen.
Eastern North America just got its first million. We're at 1 billion people now. $2 billion, $3 billion, $4 billion, $5 billion, $6 billion, $7 billion, $8 billion, $9 billion.
Our population is expected to grow to 10 billion by the end of this century. Yet the Earth's size remains the same. Slowing human population growth and lowering our use of natural resources are key to reducing the impact we have on the planet. Through the decisions we make about our lifestyles, our numbers, and our consumption, we can all help preserve the health and beauty of our home.
So I hope that you found that very interesting for you. I know every time I've watched that, I am amazed about how fast the population started growing. And so that really is an example of exponential growth. And that's why we're having this unit in our environmental science course, is to explain what has happened and what's expected to happen. So we grow by about 80 million people per year. I mentioned as the video went on how long it took to get to our first billion, and then very, very quickly it was even hard to keep up with, okay, 5 billion, 6 billion. So it only took 30 years then, once we had 2 billion, to reach to 3 billion. So that's that J-shaped curve that we've seen when we were talking about animal populations, but that is what the human population is experiencing as well. And so because of this exponential growth, there's a fixed percent increase. So even if the actual growth rate remains steady, the population size is going to continue to increase. And I think that is hard for people to quite understand, but you know, basically we have this fixed growth rate that we've been undergoing for a long time. And so the people are already here on the planet that are in this pipeline. And so we're at a little over 7 billion people now. And so let's say half of those are women, so 3.5 billion are women. Let's say half of those 3.5 billion are of reproductive age or are children. um, and they all decide to have one child. Boom, you can see real quickly how we go to 10 billion people really, really quickly. It did mention to you, and you watched in the quick video I showed you about sort of how things stayed very slow for a long time. And then as technology came in and the Industrial Revolution came in, it definitely that influenced the human population dramatically. On this graph and in the video, you did see that little dip, and I'm going to let you think for a minute what happened in the late 1400s that caused the human population to dip down. And if you're thinking the Black Death or bubonic plague, you are correct. So that was actually enough to cause enough millions of people to die that it's showing up on this graph, which is in billions. So China's program is really the nation that has the very best well-known population control program. And so let's talk about this a little bit in depth for a variety of reasons, including the fact that quite a few of our students are from China. And so why did the Chinese government institute this population control measure, right? Why did they do that? Well, we have to look a long time ago, back in the 1970s. And at the time, there were about 790 million people. Fresh water and food were already at a premium, and that was just with 790 million people. The country was experiencing a big momentum in population, and the numbers were rising very quickly. And because of infrastructure and some of the other issues with fresh water and food, millions were expected to die from disease and starvation in the upcoming years. And so that is why the government stepped back and said, we need to do something, and something pretty dramatic, or we're going to have an awful lot of people suffer. And so that's why they started the population control program. And these are some of the promises that the government instilled in order to get people to go along with this. So they promised free education and health care, increased personal and family income. They increased the legal marrying age for women. And now this is an interesting step here, and I'm guessing I should know that age because we've talked about it before. How old you have to be to legally marry in China? It's in your 20s. I know that. In the United States, people can get married as young as, I believe, 14 or 15 years old with their parents' consent. So by increasing the legal marrying age for women, then that gave women better educational opportunities. They could stay into school longer. They could explore having a career before they started having children. Contraceptives, abortions, and sterilizations were all free of charge. And there was no stigma associated with looking for those services. There was preferential housing and retirement income promised as well. And this is another important strategy to getting the population to go along with this, because just like many countries out there, and as the United States used to be, when people would get old, they would depend on their families to take care of them. And there were no special pensions or senior care living centers or anything else like that. So if you were unlucky enough then to maybe not have any children or have any surviving children, then there was a real worry about what would happen to you when you got older. But now the government is stepping in and saying, we are going to give you some retirement income and we're going to help with your housing. And so that alleviated a lot of concerns about not having more children. So this is the one child policy and sort of how it affected the fertility rates in China, how there was a steady decline. And I think it's interesting here. So total fertility rate is the number of children, live children, that a woman has during her lifetime. That is what the fertility rate is. And so if you look at back in the 1970s, on average, women were having between 5 and almost 6 children each. And so that is a very high number of children being born per couple. If we look at by the time the one child policy was actually became law and was instituted, that total fertility rate was already dropping. It was already on the decline. But in any event, in the late 70s, this was the policy for China. And it stayed into existence for a very long time, over a decade. And during that time, couples were supposed to only have one child. So what are the impacts of this if you are having less than below replacement fertility? And the replacement fertility rate, I'll just tell you now, it's in a slide a couple away from here. The total fertility replacement rate is 2.1. And so the idea behind that is that you have a man and a woman, and if they have 2 children, they replace themselves. So that's really what that means. So anything below 2 would mean that the population would be getting smaller over time. Anything above 2.1 would mean it's getting larger. And the reason it is 2.1 and not just 2 is to allow for sometimes children, right, don't make it into adulthood. So there is childhood mortality. And so that's why the replacement fertility rate is on average 2.1. So, the rates that were happening here were already underway, and they are hard to reverse once the numbers fall below replacement fertility rates. So the key impacts here, that there was a distorted sex ratio at birth. Less women were being reported being born. That's because in the Chinese culture at the time and in a lot of countries around the world, male babies are preferred. And so even in English countries, it's the males that carry on the family's name, right? There was a skewed age ratio where we have very few young people being born and quite a few middle-aged and seniors there. So that's a skewed age ratio. There's a decline in how many people are then able to go into the labor force. The population is getting aged and there's a lot of them. And so there's a very high dependency ratio of aging people to the number of workers. And so these are some of the impacts of this policy. And so it has led to a shrinking workforce in China. This graph shows approximately people that are over 60 are in the gray bars. That's kind of funny because we all get gray hair, right? The people in the green bars are aged 15 to 59. And then everybody in blue would be considered to be a child or an infant. And their ages are 0 to 14. So if we look at the effects of this over time, we can see that real quickly from 1964 to 82 to 2000, there was a very steady drop in the number of 0 to 14-year-olds. And that continued for a long time. It still is, right? And so then if we look up through 2035, which, is not very far, 2020, we can see that there are a lot of folks in the middle age group, and then quite a few people compared, relatively speaking, a lot of senior citizens. And that has a lot to do with how much longer people are living than they used to live. And there's a lot of them because they were already here before this policy started. And so this graph kind of shows in millions of persons a decline in Chinese workers as well. And you can see the drop down here at 2020. And so this is of concern, right, when there are not enough people of working age to support the economy and to support all the senior citizens. So there are also approximately 30 million wifeless men this year, meaning that there were 30 million fewer women than men. And this will be the surplus in time if that sex birth ratio stays the same. By 2050, there could be 37.5 million wifeless men in China. And I want you to just stop and think a little bit about what does that mean. We have these millions of men who are not going to have a wife. They're not going to have a family. Their life is going to be very different than maybe the family that they grew up in. And so what does that mean for the culture? How did this come to be? And these are all results of the one-child policy. Now, in 2015, the Chinese news agency announced plans for the government to change the one-child policy. And so now all families are allowed to have 2 children. And the point of changing that policy was to improve the balanced development of the population. And so that is really acknowledging now that there is an issue with the female to male sex ratio. And this also is designed to help to deal with that aging population. But I've asked a lot of my Chinese students over the last maybe 3 or 4 years, and I would say the vast majority of my students have a sibling, and they have had a sibling. So I think even before this policy was announced in 2015, I think many people in China were already having more than one child. And so how will that policy change affect the population policy overall? And so this shows you 3 different scenarios. The red line at the top would be if 2 children were born to every woman beginning back in 2016. The population would peak at 1.46 billion people. If there's a gradual increase where most families are still only having 1 child and then a gradual increase, the population would peak in 2030 at 1.43 billion. On the other hand, a lot of people are happy only having 1 child, right? They can give them all their love, all their attention, all their money. And a lot of you maybe are only children, and you see the benefit in that. And then the population in China would peak in 2030 at 1.42 billion. So there are quite a few more births that are likely under the new policy there, approximately 23 million more people, unless everybody all of a sudden decides to start having large families. And there's a little asterisk there that that red scenario is very unlikely to actually happen. So either the blue or the green line is probably more accurate about what will happen. So right now we have about 7 billion people here. The populations continue to rise in most countries, particularly very poor developing countries are still having large population growth rates. And so even though the rate of growth is slowing, we are still absolutely increasing in our numbers. India, if not this year, very soon will surpass China as being the most populous country. I need to look that up soon, or maybe somebody can Google that real quick and see how close they are, because I think India might this year have more people than China. And so there's a lot of questions here. Should the government or society influence how many children you have? And then I'm wondering what U.S. policies promote or discourage births that you can think of. So anything that would favor large families, that would be promoting them. Anything that would discourage large families, that would be something that would make the population smaller. And then what societal pressures promote or discourage births? One of the ones I can think of right away are maybe your own parents. Maybe they can't wait to be grandparents. And so that might be, a pressure upon you where you know that your parents are expecting you to have children in the future. And I think that's really an interesting idea. In some countries, religion forbids people to do anything that would interfere with natural reproduction. In other countries, that's not the case. In other countries, it's sort of, men and how manly a man is. It depends on how many children he's sired. And so there are across the world many, many different ideas about this. And certainly, I've grown up in the United States where, most of our policies do tend to promote larger families. A lot of the policies do. So think about that and see if you can come up with a couple of good examples. And why don't you pick the country that you're from or the country that you're most familiar with, and think of something that would promote or discourage a birth, and what kind of things in society would impact whether or not people would want to choose to have children. The growth rate really varies here from region to region. Right now, there's a global growth rate of about 1.2%. Under that, the population is going to double in 58 years. And the highest growth rates, and you can see that here, the orange and the yellow or the red graph, all of these have very high growth rates, and most of these are in developing countries. So just think about that. The population could double in 58 years, and most of you are in your 20s, and people are living longer and longer all the time, and so you all will be around, hopefully then. I won't be, but you will be. And so when you're in your 70s, what would the world look like if there were 14 billion people? What can you imagine some of the issues might be if there are 14 billion people? That's a lot of people, isn't it? So is there some kind of limit to population growth? All of the improvements that we have done in technology, sanitation, medicine, and food safety and food quantity, all of those things have reduced infant mortality rates. And so death rates drop here when this happens, but not the birth rates. And so a big question is, what is the Earth's carrying capacity for people? We talked about the carrying capacity, I think, in chapter 2. And I ask you then to think about, is there a carrying capacity for people? So with lots of different people weighing in on that same question, Um, Basically, they come up with that there are enough resources in the ecosystem could sustain 1 to 2 billion very prosperous people, um, or 33 billion very, very poor people. And so that's the best guess about what is the Earth's carrying capacity. I think the fact is that people aren't really sure about it, mostly due to technology, right? We're constantly changing our carrying capacity. There was a famous essay written back in 1798 by Thomas Malthus. He wrote an essay on the principles in population. And according to him, back in 1798, there was not going to ever be any kind of overpopulation issue, that war, diseases, and starvation would eventually reduce populations so that we didn't really need to worry about population growth, that these other things would take care of it. Well, that's really not the case, right? Because there's 7 billion people here. And so there's different views on population growth for sure. Back in 1968, Paul Ehrlich wrote a book called The Population Bomb, and he predicted that population growth would lead to famine and conflict. But basically, through technology, we figured out how to feed more people. And so we've increased our food production capabilities, and we have fed more people. A lot of economists think that depleted resources will be replaced and possibly new resources will be created. But, those are economists, not biologists, who are saying that. And a lot of resources like biodiversity and species, they cannot be replaced, right? Once they're extinct, or their numbers are so low, that could be a big problem because they're all needed to have a functioning ecosystem. The quality of life will suffer with unchecked growth. There'll be less space, less food, and less wealth per person. And I can see how that could happen, especially in certain countries for sure. Population growth really is only a problem if it depletes resources, it stresses out social systems, and most importantly, I think, it degrades the environment. So if the environment in any way is diminished, then that means that it has less things available for us, right, that we can use. So there's a couple of different models that have been used to construct how population impacts the environment. And so this model is called the IPAT model. And I stands for the impact of the environment on the environment. P is the populations. It's the individual's need for space and resources. Affluence is the A. That's basically per capita resource use. So very developed countries like the United States and China, we have high affluence compared to other places, and so we have a higher per capita resource use. T is for technology, and so that's saying that we're going to increasingly be using technology, and that should help protect resources, right? So technology should make more resources available, and it should protect them. There's a fourth factor that a lot of biologists want to include in this model called the S factor, which accounts as sensitivity. And this is saying, well, not everywhere around the world is created the same, right? We just finished discussing all those biomes. We talked about net primary productivity, meaning how many plants can grow in an area. And certainly some of those biomes would be considered to be very sensitive to human development. Mostly places like the Arctic tundra and the desert, right? They both have very low primary productivity. And so if people move in and start doing anything to that environment that could affect that, that could actually lower how many people that area could support. So most biologists think that we should include this S factor, the sensitivity factor, when we talk about this model. And so China is a good example of the IPAT formula. We can show that there are different elements of that formula that can combine and can cause a big impact in a very short time. So China is doing rapid development. Its economic development is amazing. And it's causing very unprecedented environmental challenges within China, right? There's intensive agriculture to feed all the people. Can lead and is causing farmland to become eroded. The mighty Yellow River, which was one of the largest rivers in China, has been used for irrigation, and sometimes that river is almost dried up now. There's a lot of urban air pollution and massive traffic jams because everybody wants their own vehicle, right? And unfortunately, the lifespan has actually decreased 5.5 years for Chinese men. I don't know why it only is allegedly for Chinese men, but the lifespan has actually decreased. And a lot of this is because of the changes that have happened in the environment. So the word demography is basically the study of human population. I believe we've touched on this before, but applying the principles of population ecology to the study of change in human populations, that really is what demography is all about. And so what are they studying? They're looking at the size of the population, the density and distribution of where the people are, the age structure, the sex ratio, the birth, death, immigration, and emigration rates. We've talked about those before. And so those are the things that that demographers would actually study. And you guys, these numbers are not accurate. They're a little off, right? Because there's people being born and people dying all the time. But this will give you a pretty good idea about the size of some of these other countries, how many people there are there. China's 1.357 billion at the time they made this figure, and India was close approaching. I think those numbers are all up. And so that's really where the people are. United States only has about 316 million. So compared to a lot of other countries in the world, we're not that populated compared to other places. So population size and density is kind of depicted here in this graph. And so the United Nations predicts about 9.3 billion people will be here by 2050. And I know all of you are still going to be with us by then, hopefully. And so if women just have on average a half a child fewer than what's happening now, there will only be 8, not 9.3 billion. So it's pretty easy with just some ideas about how many children people should have. It will be pretty easy to work on this. And so this graph shows you, basically the exponential growth rate there is in black, a high growth rate in red, medium is in blue, and low is in green. And so these are the projected populations in billions for the entire world. Because what happens in one country affects everywhere, right? It doesn't just stay in that one country. And so that's why we're looking at global patterns. And so humans are not, evenly distributed. We are very unevenly distributed around the globe. You saw that in the video at the very beginning when I played that. There are a lot more people in Asia than in other places. Most of the populated areas have temperate or subtropical and tropical climates. Most people live near sea coasts or major rivers. That's probably how they got to be there in the first place, and then they stayed. There are lots of very unpopulated areas with hardly anybody, like deserts and arid grasslands. And those places, again, are very environmentally sensitive. So they would have a very high S value in that modified IPAC equation. Any kind of human activity, agriculture, ranching, mining, anything like that, those areas could be very, very hurt very quickly by changing anything if people do much disturbance to those sensitive areas. If we look at, and I want to look at this kind of closely with you, these are kind of age structure diagrams, and they're all done very similarly. You're going to have some on your quizzes. I know there's one on your exam, and so they're all made kind of the same. And so if we look at this, the number of men is on the left-hand side, the number of females is on the right. It basically shows the different ages of a population. So the orange at the bottom is pre-reproductive age. I guess I should have said kind of an orangey brown at the bottom. Orange in the center is all the people that are of reproductive age. And then everybody at the top is of post-reproductive age. And I look at that and I kind of laugh because, you know, men can have babies when they're very, very old. Well, they can become fathers when they're very, very old, but only women can actually give birth. So that there's a pretty steep decline in, you know, how many children a woman can have once she gets close to 40. And so that number drops off pretty quickly. And so this is how all of these age structure diagrams work. If you see something that kind of looks like a pyramid, this would be a population that is increasing very rapidly. There's a lot of children that are pre-reproductive age, so they're in the pipeline, they're already here, they're going to just get older with time, and then they're going to become reproductive. Not that many post-reproductive age people here, so this population's getting bigger. If we look at this population, which kind of looks like a cone, it basically is considered to be stable, right? There's almost, you know, there's not a large number or a small number of pre-reproductive age. So knowing how many children you have is key to this. All the levels are, all the different ages are kind of equally distributed. And so that would be a stable population. Then if we look at the one on the far right, that's kind of like an upside down pyramid, sort of, where there's not very many children. And so this population is decreasing, this population is getting smaller. There are a lot of people that are post-reproductive age here. And I think this is a good place to kind of call your attention to this. Do you guys see how many more women there are that are older here and here and even here? That's because women tend to live longer than men. And so that's why there's more women that are older here. So again, this just kind of explains to you what I just did with the way these diagrams are all made. And so again, you can kind of look at one of these really quickly and just visually, you know whether that population is getting bigger or smaller. You look at how many people are pre-reproductive and you can kind of tell. So here are some age structure diagrams from different countries, and I think it's kind of good to look to see what's happening in other places. So places like Guatemala and Nigeria, Saudi Arabia here on the left, those countries are undergoing very rapid growth. Um, United States, Australia, Canada here in the center, or the second graph here, we're having fairly slow growth. There are some countries in the world that are actually having zero growth: Spain, Austria, and Greece. And then if we want to look at countries that are doing negative growth, there's Germany, Bulgaria, and Sweden. So what is negative growth? Can you tell from looking at this? So that means that there are far fewer children being born than in the other ages within the population. So they're having fewer than the replacement rate. They're not having even the 2.1. And here again is a good example of comparing these. I know we've looked at several of them, but I want you to make sure you understand them, what they're representing. Canada is on the left-hand side. The growth rate is 0.4%. Look how few children there are there. On the other hand, Nigeria is on the right. Look how many children they have. That growth rate is 2.8%. So their age structure is heavily weighted to the pre-reproductive years. Lots and lots and lots of children there. A lot of populations are actually aging. The global age now is 28. That's the mean age across the world is 28. If we wait till 2050, that mean age is going to be 38. And China's age structure is changing. Back in 1970, the median age at the time was 20. And by 2050, the median age will be 45. So the graphs here are all supposed to represent population in China from 1970 on the left to 2013 in the center to 2050 on the right-hand side. So I think that's really interesting when you look at the change. That's not very long, right? I know you might think it is, but just in a few decades, things definitely changed, which kind of says that if populations decide that they want to do something about population growth, that we could really do that. We can really quickly make a difference. So as far as sex ratios go, at birth, human sex ratios slightly favor males, meaning that for every 100 females born, 106 males are born. And you might think that it's 50-50, that it's always 100 and 100. But that's not the case. And we think that this is an evolutionary adaptation. Since males are prone to die during any given year of life. I think that is amazing. I had no idea how dangerous it was to be a male, but that's why the number of is a little bit different. And this then tends to ensure that there's an approximately equal number of men and women by the time everybody gets to reproductive age. And so we think that's the reason why it's skewed slightly to more males being born. So population change resulting from birth and death and immigration and emigration, these rates really affect whether the population is getting bigger, is it shrinking, or is it, basically remaining stable. And again, birth and immigration add people, and death and emigration remove individuals. Our technology, we're constantly trying to keep death away, right? We're being able to decrease death rates by use of better medicine and technology. And so we have this big gap now between birth and death rates. And that really resulted in populations expanding very quickly. There's a decrease in infant mortality that's due to, in fact, a lot into better nutrition, prenatal care for the mom, The mom actually having better health herself helps in decreasing infant mortality, and having some kind of medical person present during birth, even if it's a midwife and not a doctor, but having somebody there at birth can also reduce infant mortality quite a bit as well. If we look at infant mortality rates around the world, they are very variable. Some places, if we look at in the middle of Africa, more than 120 babies die per 1,000 live births. That has lots to do with health care and sanitation and the condition of the mom while she's pregnant and giving birth as well. If we look at Asia and North and Canada and the United States, that varies from 1 to 5 to 5 to 10 infant mortality. So it tends to be lowest in the wealthier countries, which probably isn't a surprise to you. It is highest in the very poor countries, especially sub-Saharan Africa, which you can tell there. These growth rates that are falling, they do not necessarily mean fewer people. Again, despite the decline in the global growth rate, the population continues to grow by adding tens of millions of people each year. And you can see that here in this graph. The world average is in blue. The more developed regions is in green. The less developed region is in red, and the very least developed countries are in orange. So if you look at this and you're like, well, where are all these extra people coming from? They are coming from the poorest countries. Their population growth is still very high. And so that's where those extra 3 or 4 billion people are going to be coming from. So I already explained to you a little bit about or the replacement fertility rate, but let's talk about total fertility rate. This is the average number of children born to each female during her lifetime. And so again, it's the average number of many, hundreds of thousands or millions of women. So it's usually there's a fraction there, right? I know you can't have a half a baby or 0.1 baby, but it's the average. The replacement fertility rate is again 2.1. That then keeps the population size stable. And there's several causes of decreasing total fertility rate. I've already mentioned medical care that reduces infant mortality. Urbanization actually increases child care costs. So many people maybe don't want to have a bunch of children because they don't want to spend that much money on all the kids. Maybe they only want to have 1 or 2 instead of 8 or 10. Children go to school instead of working, and the children are becoming more educated. Social Security helps support the elderly. This is very important. And educated women tend to enter the labor force. They delay having children, and they go to college, and they want their own careers, and they delay they don't have children as soon as they're reproductively able to do that. This is the rate of natural increase, the change due to birth and death rates alone. And this excludes migration. So people moving is not included in that. And if we look at these total fertility rates per region, Africa is the very highest, 4.8. The South Pacific, including Indonesia and Australia, is 2.4. And then it goes down to there. So many places in Asia, it's just slightly above the replacement fertility rate. North America and Europe, some of those countries are lower than the total fertility rates, meaning that their population is actually declining. Many countries have experienced something called a demographic transition. And this is basically a model of the economic and cultural changes that happen as nations become more industrialized. They move from a stable sort of pre-industrial state of having very high birth and death rates, and then they move to a stable post-industrial state of low birth and low death rates. Industrialization decreases mortality rates, and so there's really no need here for big families. We don't have to have 10 people, or 12 or 15 kids to work on the farm, because they aren't working on the farm, right? Their parents have other careers. They're not doing kind of manual labor like that. The parents really invest in the quality of life, not the quantity of children that they have. And the death rate then ends up falling before the birth rate. And so as countries and populations grow through this transition, there can be a short temporary population growth that happens here, basically because the death rates fall before the birth rates, and so it can slightly go up there. So I'd like you guys to stop and think a minute about, well, how many children do you want to have? Or some of you may not want to have any. So I decided not to have any children of my own, so I adopted 2 boys, and that was a choice that I made. So I decided to have 0. And so I'm wondering how many children you want to have. I wonder how big is your family. So including you and your mom and your dad, how many children are there in your family total? Now I want you to step back and stop and think about your parents' families. How many aunts and uncles do you have on both sides? How many sisters and brothers did your parents have? I bet you that number is higher. My dad was a family member of 8, so he was one of 8 brothers and sisters. My mom she was from a smaller family. She only had 3, but my dad had 8. And so I'm wondering if that's the case for you too. How many people were in your family? Families used to be really big. It was not uncommon at all for families to have 10 or 15 kids. I know, I can't imagine dealing with that, but that is true. And if you don't know, why don't you ask your parents, and then even have more fun, and if you can get a hold of your grandparents, ask them. I'm guessing over time, those family sizes have gotten smaller and smaller. If you can compare maybe your grandparents' size families to what you grew up in, I bet it's smaller. These are the 4 stages of the demographic transition. I kind of went over those. Please study these. I think it's pretty simple to follow through what happens. And try to figure out if you can just think about all the countries in the world. Read these descriptions and see if you can figure out a country in the world that would basically be a good representative of each one of these stages, right? So you have to think about how much population they have. Do they have disease? Are people starving? Or is it all post-industrial? So the population is having very low birth and death rates. So try to think of some examples, and that'll help you remember this easier than you trying to memorize the different stages of what happens. This transition, we can go back in time and look at almost every culture, every civilization, every country, and we can follow it along. And this seems to be how all populations change over time. So here's a little data question about demographic transition. At which stage of the demographic transition does the population increase the most? So now you need to learn to read this graph. So you need to see how fast is the population actually growing. And is the growth greatest at the beginning or the end of that stage? So look at that and try to make some sense of this graph. I believe you're going to see this graph again. Again, if you can figure out a country which represents each stage, it'll be easier for you to remember. Is the demographic transition a universal process? It really has occurred in almost every nation over the last 200 to 300 years. It may not be applying to developing countries. And the reason why the transition from less developed to more developed could fail is if the population is too large. The population is too big. There are already not enough resources. The environment is in bad condition. It's possible that different countries could get stuck along the way and that they will not be able to transition from having very high populations to low populations. Also, if the culture, and you have to remember different people have very different cultures than maybe what you have grown up with. If their culture places greater value on childbirth, and if women don't have they don't have a say in how many children they're going to have, because there are countries that are like that, then that transition may fail as well. So basically, if everybody on the planet were to live like people do in North America, we need the natural resources for 3 more Earths. So think about that for a minute. Think about all the resources. We've talked about affluenza. Everybody can't live the way you do. They can't have multiple TVs, multiple cars, living in individual homes. We don't have enough resources to support all of that. It's just not going to work. So this is a good place for us to stop here. And we'll finish up this chapter next week or our next class. And I'd like you to just stop and really think about, your ideas about population. People at your age already have interesting ideas about number of children and people having too many children. What is too many children, right? Who is supposed to decide that? So let's quit there and you guys work on your homework for this chapter. It's already posted, and I'll see everybody next class. As soon as we finish this unit, that will be time then to have your actual exam. All right, I'll talk to you later. Bye.